Hi, I want to take a look at a problem involving the basic kinematics for a horizontal spring mass system on a frictionless surface. So with a spring mass system, we need to have a spring connected to a mass. So our spring has a spring constant or spring rate of 20 newtons per meter, and the mass is 200 grams. And it's displaced so that it has a maximum amplitude of 3 centimeters. So with all simple harmonic systems, there's a natural frequency omega. And for spring mass systems that are horizontal, our natural frequency is the square root of the spring constant divided by the mass. So if I take the square root of 20 newtons per meter, which is kilograms per second squared, divide by 0.2 kilograms, that gives me 100 per second squared in the numerator. So that gives us a natural frequency of 10 radians per second. Now, the other frequency, the frequency f, which is the number of cycles per second, is our natural frequency omega divided by 2 pi. So if I take 10 radians per second, divide by 2, divide by pi, I get a frequency of 1.6 hertz. Now, the period is going to be 1 over the frequency, f. So 1 over that gives me 0.63 seconds for each cycle. Now, in terms of maximum velocity and maximum acceleration, they're related to the natural frequency omega and to the amplitude that we're dealing with. So our maximum velocity is going to be our amplitude times our natural frequency. 10 radians per second times 0.03 meters tells us that we'd have a maximum velocity of 0.30 meters per second. And for acceleration, it's amplitude times omega squared. So we multiply that by another 10 radians per second. We get a maximum acceleration of 3.0 meters per second squared. So the final piece, if we want to take a look at the energy that we have in that oscillator, we could look at the energy when we are at our maximum velocity. From kinetic energy, it would be 1/2 times the mass times the speed squared. We could look at the maximum potential energy when our spring is stretched out to the amplitude, which would have 1/2 times the spring constant times the amplitude squared. Either way I do it, I'll get the same result. So from the second piece, 1/2 times 20 newtons per meter gives me 10 newtons per meter times 0.03 meters squared. That's going to give me 9 times 10 to the negative 4 times 10, which means I have an energy of 9 millijoules, 0.009 joules. Thanks for watching.